Hi. I'm Mike Kearney. I'm going to give you a quick talk today about my research called Bots of the SOC, which is my attempt to build an autonomous agent to automate solving the Splunk Boss of the SOC challenge. So a quick bit of the scope. I'll just give a bit about my background, who I am. Go over some of the AI terminology to make sure that some of the terms I'm talking about were all clear, exactly what I mean by that. And then look at why the methodology here is different. I'm using an agentic way of solving threat detection rather than a traditional deep learning way. I'm then going to go into a bit of explanations to how it works, and I will do a demo, which hopefully, fingers crossed, everything will work as intended. I'll briefly sum up some lessons learned and areas I think would be interesting to further develop this research. So a bit about myself. I'm Mike Kearney. I served 12 years in the Army, mostly in cyber operations and cyber intelligence. I've been interested in researching AI and NLP particularly since about 2018, starting with some funny projects back when hallucinations were just comical rather than actually seen as a threat, where I did some optimization and retraining on GPT-2 offline to make a comedy Twitter bot. I'm currently head of cyber defense at Leonardo UK, which is an aerospace and defense prime. And this is my first time speaking at a cyber conference, but many time visiting. So some of the basic terminology here. AI as a whole is basically the study. Artificial intelligence is a broad term for the study of anything to do with machine intelligence. It's a very broad term. It's the earliest term. A subfield of that is machine learning, which is where we talk about the algorithms, more modern algorithms that we may start to use to actually implement that. This is where you're talking about something a bit more tangible, some actual algorithms, stuff like your KNN, linear regressions, random forests, and so on. Within that, you've got a subfield called deep learning, which is still part of AI, still part of ML. Deep learning is when you're generally talking about not having to manually extract features. You're letting the machine figure out the features from a raw encoding. A subpart of that, which is the most common part, is neural networks. Within that is transformers. So that's the sort of what the terms mean. Why I'm sort of highlighting that is I think the artificial intelligence term now, where we've sort of got to, means that there is a difference in approach towards like an AI, AGI type, agentic type approach of threat detection, which is beyond the sort of deep learning. So I think the deep learning based approach, which I'll go on to what I mean by that. Eventually, the idea was at some point someone hopes that an AGI type thing would emerge from this. So what I mean by the different approaches, the sort of deep learning approach to threat detection, is you take your computer, your data source, you either feature extract or encode some data from that, you fit a model on that, you do some prediction, and then you detect your threat. That's sort of how most, neural networks, CNNs, most types of I'm saying traditional, and for technologies only existed for a few years, traditional deep learning based threat detection would work. The agentic way, or you could say inverted commas light AGI way, is rather than sort of building a model with weights that focus specifically on a certain threat category which you give some human readable or context to a machine, you give it some tools which are the same as a human threat analyst would use, you give access to the machine can then work with the tools based on the context you provided to try and then find the threat in a very, very similar way to a person would. So what I've always been interested in this concept of could you get a machine to, rather than optimize weights for a specific purpose, to get it to actually learn how to use the tools and attack the problem in a very similar way a human would. Now, I'm not saying in any way that what we have currently with LLMs is AGI, but this is the same methodology you would use were you to have AGI. And I do think there is a very interesting generalization here in that rather than having weights that are optimized for a specific problem, say finding a particular brand of malware or finding a particular threat in DNS or network traffic, exactly the same weights that you can use for this problem could be used for giving legal advice, could be used for building comedy song lyrics, or could be used for finding threats in data. So I think there is a light, lowercase g generalization about some of the more cutting edge foundation models that opens up a lot of interest. So I'll just briefly allude to, actually I'll come to that one later. I'm going to hit that one later on. So I thought this is an interesting approach. I've been playing with the idea of using large language models to try and assist security operations since GPT-2 came out back in 2018, but it was really bad. It wouldn't really work at all. I even tried some local optimization and retraining on some of the Splunk commands to see if that would help, and it still made too many errors. It confused the pipe symbol of Linux commands, and it used to continuously think it could just inject awk into the middle of an SPL. That was a really common theme in some of the older models. GPT-4, particularly GPT-4o, seems to have been a lot better at that. So I had this idea of developing an automated SOC bot, like a co-pilot for SOC before that term came out. And I realized the Splunk published the boss of the SOC datasets. And these have answers, datasets, published. This would be a really good evaluation to use for this type of agent. So then I sort of focused my research then on saying, okay, let's take this as a good benchmark evaluation, and let's see if I can build an agent or an AI that can perform well against this benchmark. So I'll go back to this general AI at the moment. A lot of you have probably used ChatGPT. So you'll have a conversation with it, you'll ask it some questions, it will respond. In this context, you know that the AI can track your conversation within the conversation. Like when I said the word there at the end, it knows that that refers to moon, right? I'll go on to why this is important. So these are your questions. As a user, you get to put in input, which is your user input. The other bit of input you get to control is effectively something called the system message. So you have a system message, which is like a pre-prompt, something that just exists at the beginning of the conversation and frames the whole conversation. You control that. You control your text. And when you use the ChatGPT web interface, that's sort of what you see. When you use the API, though, it doesn't remember anything within the conversation. You have to give it the whole conversation for every single request, every time you want an answer. Now, why that's important for agents is basically when you use ChatGPT, you only see you're inputting ChatGPT in the web interface. You only see you putting in data every time you add to it, and you get a very long conversation. When using the API, you have to give, for every response, I have to give the entire conversation up to that point. And where it's billed rather than a monthly bill, it's billed on token use. You end up with agents with very, very, very large token usage before you start to get any work done. And that means it can get very, very expensive. And you really need to think about how you optimize your context window and your token counts. That becomes one of the biggest challenges in developing these sort of systems. So evaluations of work, a lot of them, like the most famous ones are like the MMLU, where you would just simply give a machine a single question, it would reply in a single response, and it would be marked correct or incorrect. A lot of reinforcement learning, human feedback, uses these sort of evaluations to optimize the model to give you the right answer. But that's not necessarily what I want in an agent. There are some other ways you could do that. There's something called end-shot learning, which is where you give it examples of different questions and responses, and it has been proven that often gives better results. You can also do other tricks, such as chain of thought reasoning, where you amend the system prompt or the text to say, work it through step by step. That proves, because of how next token prediction works, is more likely to give you a better answer. But all of this still, even the end-shot learning thing, this is still, it's end-shot learning that you're giving examples, but it's still single challenge, single response. That's good for a chatbot, but that's not what I want for an agent. For an agent, I may have a question, and there is no way the bot could possibly know the answer to that, either from its training data or from its effective world model that it can infer from its training data. So I ask it a question like, what have I got here? There's no way it could possibly know that. I have to get it to tease that out through multi-steps. So by giving it access to tools, I can get it to deduce what it might be, and then it needs to answer its question at the end of a step. Now, some of the models, I think I've got reason to believe that GPT-4o may be more optimized towards these actual sort of multi-step deduction tasks, because it seems to perform a lot better at it than any of the others. But the previous way of evaluating models on benchmarks like MMLU is purely just challenge response. I say even end-shot learning is still one challenge, one response, which optimizes the model to try and just go for the answer straight away, even if it's a really dumb response, rather than realizing it doesn't have to do it first step. It can work itself through. So that's what I want for an agent. I want a model that realizes it is part of a bigger conversation and doesn't have to get the answer first time. So going on to my sort of architecture, a simple agent unit effectively is a single LLM and then a tool, which is known as a user proxy. The user gives the challenge or the problem to the bot. The bot then is taught how to use the tool. Just it's in the system prompt. You give it the function details, instructions of what inputs and outputs it will produce. It can then call function requests and then use the tool to answer its question. That's the most simple, basic atomic unit for an agent. You can also do other architectures, which is group chat, where you have multiple agents in the same chat. You can give different ones of them different personalities. You could even use different models. You could have a mix of Gemini, Claude, and OpenAI models in the same group chat. That can have advantages. I also found it could be quite useful to have a bot which is deliberately named a sense checker bot. You tell it your role is to point out why the other bots are wrong and evaluate their logic. To avoid rabbit holes, I've also found it can be really interesting to not to give the sense checker bot a deliberately short memory. Because what happens is they end up agreeing with each other, and I've had many examples in my test runs where they end up going down a rabbit hole and they think user agent is the username, and they're not realizing that they're all thinking the word user agent means username, and they're getting confused and they're not correcting each other. But if you ask ChatGPT what's wrong with this as a single one-off prompt, it will tell you straight away what's going wrong. So what can be quite useful is give your sense checker bot a really short memory, so say it only remembers the last few messages. There's a theoretical one here you can do, which is, well, I've done this, I've tested it, is hierarchical agents. So you give one bot the ability to produce and spawn sub-agents with agent units. The idea being you keep your context window clean for the big picture problem and allow the deep detail to go into this. In practice, I've found this doesn't work anywhere near as well as I would hope. So the key to this challenge is, I've found, is to getting that function query correct. Now, the actual function query, function I'm using is quite complicated, but the trouble is Splunk could produce like 50,000 rows of text. It could produce gigabytes in a single return. That's going to completely destroy my context window and just blow the model out the window. It's not going to work. So what I do to get around that is I basically have this sort of pseudocode. So I will initially check that the query is formatted correctly before passing it to Splunk and just like do a bit of manual debugging. I'll then try the search. If it doesn't search, I would do a debug function. The functions with a little robot side mean they're a hybrid AI classical programming function. So that will actually call a large language model as part of its logic, just as a single shot, like, here's a problem, solve this. It will try and debug itself with an AI function before returning the result. And then the key one here is handle long responses. So what I'm currently using for that is because I want the reason, like currently GPT-4 is the only one that actually can Splunk well, and the only one that's intelligent enough to work through some of the more high-level technical problems, but it is limited context window and it is expensive. So if I have a response which is above a certain amount of characters, I then send that to Gemini 1.5 Flash to summarize, because that has a million context window and is much cheaper. It doesn't need that bigger level intelligence. That then summarizes the key bits in the context of the question. I don't just pass the response, I also pass the question that I'm trying to solve into it, so it can like give it a bit of context to say, if you see this in this data, summarize it in regards to this question, and then pass that back to the main agent. That then optimizes the context window and doesn't pollute it with noise that's not relevant, and then return the results back to the agent. So what I did, and I've got this now, I've got Splunk is my tool, I've got my agent set up, and I've got a person. But I said at the start I wanted to automate boss of the SOC dataset without human in the loop. So rather than having a person input, I've just given it a document with JSON format with all the questions for boss of the SOC. I pass that into the machine. I can then let it run an evaluation run. It will work through the questions. It also has the answers in a separate JSON. Because I didn't want it, sometimes it says the answer is, say, google.com rather than just google.com. I didn't really want extract string matching, so I use another bot, which is my marker bot, just to say, with this question, this answer, do you think this is correct? So it marks more like a human. It then appends that to the results, so I can just leave it then to automate it go for an evaluation run. So I wanted to do more runs, but it gets quite expensive to do a run. So I've been tweaking it. My last run I did earlier this week with GPT-4o and the Gemini update. So I did it. I run it on a few things. I run 20 questions through the bots of the SOC version 2. It got 7 of them incorrect. It got 13 of them correct. So it got 54% of the answers correct. But obviously, as anyone who's done Splunk boss of the SOC knows, they're weighted questions with different points. So actually, its point score was slightly better. It scored 65% on my last evaluation run on boss of the SOC version 2. I think that's pretty good. That's probably on par with a junior analyst or really reasonably entry-level person, first attempt. Does make some dumb mistakes. It's amazing how a model can be so smart. Sometimes it gets there's some SQL injection stuff it gets, which is quite a high pointed question. It gets it basically every time. But then it also makes dumb mistake, like thinking user agent is username. So it's not like a person. It gets some stuff really clever and some stuff really bad. So demo time. So what I'll do is I'll just move that down and I'll do a quick run of the, and hopefully this will work. If I move this across to here, don't know how big the text is. I don't know how well you can see that, but I'll try and read out any bits that are, and I should have got this lined up. That I should have it just ready to run. So I don't know how clear the text is for that, but I'll try and point out anything interesting. So this is just going to do a run on the Boss of the SOC version 2 question set, and initially it will load the question, which it did very quickly, so I'll scroll back up. So yeah, so it loads the question here. You can see, gives it the question. I have given it the hint, which comes from the question, but I haven't given it the starred out, as you get in the, on the actual proper one, you get the starred out answer, so you know how many characters it is. That probably could help it. It's then constructed a query. It's hit my debug function first, managed to debug itself with a sense checker bot. And now it's given itself the correct query. So here the question was to find what site Amber Turing had visited. It correctly identified that to do that, it needs to stats by her IP address, which it's done. It's now identified her IP address. It's now realized it needs to query source type stream HTTP based on the IP address. It's just inferred. So I didn't give it the IP address, so it's worked this out itself. And it's doing stats values site as site. So it's going to give me a list of all the sites. That's going to be quite a big response. It is quite a big response, and it's picked out from that. Actually, it's figured out that the answer was burkebeer.com. Now the question did say it's a competitor. So this is where the general intelligence comes in. It knows that it's something to do with beer. It knows it's a brewery, so it's figured out, oh, that one's called Burke Beer. That's probably a competitor. That's probably the answer. So I think that's quite interesting how it's general world knowledge. I've sometimes seen it do stuff where it does a specific, says search for beer, hop, brew in the site title, and it's just decided to do that itself, which I thought was quite interesting. So that's the sort of quick demo. I could let it run a bit longer, but it generally works its way through. I say it scores on average about 65%. I'll just quickly bring up some interesting examples of where it's gone wrong. I minimize that and bring that across. So again, text isn't very big on this. So this is where it can be really dumb. So here the summarize function has been called, and the summarize function has said that the answer is this attachment name, which you can't actually read this. It's then ignored that and decided it's still going to cry because it didn't get the field right. It's got obsessed with getting its field name right, and it's just keeping going. It's got the answer. The answer is right there in that text. But I think this is where large context window recall becomes a problem, and a lot of research has shown GPT-4 recalls data, the needle and haystack test. It recalls data from the start of the context window or the end of the context window, but not in the middle. It gets quite bad. And Gemini generally performs a lot better at that. So here it's got the answer, but it still continues to go, even though the answer is there. It didn't realize it had the answer and respond with the answer. If I go back to sort of next steps then. So next steps, I'd like to experiment with other large language models other than GPT-4. I think there'll be Splunk detection labs publish a lot of detection logic online with it's very high quality training data because they have the Splunk search and they have the plain English description of what it does, and there's quite a lot. So I think by retraining on that, you could probably get a local model to optimize to Splunk searches. I'd also be interested in if you're doing it with a local model fine-tuned, or maybe a hybrid group conversation, maybe have something like Llama 3 optimized for SPL, combined with a higher level brain, which is something like GPT-4. Then look at something like reinforcement learning. So get it to actually run, and then every time it gets the right answer, or put some sort of, I haven't quite worked out how I'm going to do this, maybe some sort of feedback for how many iterations it takes, or how many tokens it takes to get the answer, and then give it a reward function for the reducing the amount of tokens it takes to come to the answer. The only problem with that is I would need quite a large data set. I'd probably need access to every one of the 8 current Splunk Boss of the SOC data sets, and then maybe a bit of randomization with various random seeds to get that to work. My concern with the reinforcement learning on the amount of data I've got available to me is that it would overfit to and memorize that one problem set. But yeah, these are areas I'd like to explore more. I'm definitely interested in, I think Gemini is the one that's showing the most promise. And I know Ultra 1.5 was released since I last updated my attempt at this. So I haven't actually tried running that with the model. I briefly tried Claude, I briefly tried Llama. Both of them did not work at all. But Gemini seems to be showing the most promise. So that's all my slides. So contact. I'm on LinkedIn. I do publish, put some posts up about research on there every now and again. If anyone's interested, reach out. So that's all for my talk. Has anyone got any questions?